My name's Rob. I'll be your MC for the afternoon, and really excited to introduce our first set of speakers for the afternoon. So we have Juan, Jason, and Daz, ninja rockstar parachuting in software engineers from Microsoft, here to tell us about their many adventures in EdgeDevOps. I did not even know that was a thing. That is awesome. Take it away, guys.
Thank you for that kind introduction. So good afternoon. Hope everyone's had a good lunch and ready for the afternoon sessions. My name's Dasith, and Juan and Jason, we are part of the Microsoft CSC team. And over the last probably 6 to 12 months, we've been working a lot on edge devices. And this talk is about sharing some of our lessons that we've learned along the way. We've got a lot of scars to show. And without further ado, our team is one of the 3 dev crews based in Australia. And we are a government-aligned team. So most of the work we do are for governments, so more mission-critical software that runs on the edge. But we've all come from a cloud background, so we wanted to use the more modern ways of writing software and orchestrating software running, so that's Kubernetes. And these lessons we learned from running Kubernetes on the edge. So the agenda for today, we're going to talk about what Edge DevOps is and how that differs to your normal DevOps practices, why it's special. We'll talk about our development workflow and what's worked for us, our inner dev loop. Then we'll touch on about the more interesting parts about the connected and disconnected scenarios of these edge devices and how we've solved or how we've kind of figured out how to deploy software into it and do the ops around it. And lastly, we'll talk about how we've got these devices to discover each other and work in a network with auto discovery. So moving ahead, Edge DevOps. So this is I'm sure that we are not the first team to come up with this term. This is just a fancy way of saying just DevOps on the edge. But why is it special? Why can't we just do our normal DevOps practices? Well, it turns out that there's a lot of constraints on the edge. So namely, the network that we love, the internet, the public internet, we don't have the safety wheels of being able to get anything off of the internet we want. So imagine you're deploying something, you want an image from a container registry that's maybe Docker Hub. It's not available on the edge. So you need a way of having those images available. And also latency, you need to basically have most things just one hop away, because you need a consistent experience, because some of these are mission critical devices. And you can have one to many devices running. So I'm sure anyone who's developed microservices here would understand or heard the term that you need to treat them like cattle rather than pets. This is definitely the case for us with devices. Devices can come and go, devices can get lost. So therefore, they need to participate in the overall workflow pretty easily without treating them, attending to them individually. So this is where the choreography part comes in. There's no central thing that manages that. We would like for everything with minimal configuration to be part of the entire fleet and be able to contribute to the solution. So first step of that is having a consistent development experience, because we are developing on devices that have special needs, special platforms. So to have that consistent development experience, we've gone through a workflow that's really nice. And to talk about that, I'll ask Jason to come along.
Cool. Thank you for that, Daz. So I guess before we start any project within my team, well, it all starts with the inner development loop. And the common problem we have is how do we ensure everyone on the team has the exact same environment, regardless of what machines they're working with. Like for example, I use a Mac for work. The other guys in the team, they all have desktop, Surface laptops and all that kind of stuff. So it's a big problem. Like, how do we ensure that everyone has the exact same environment? Likewise, say 5, 6, 7 weeks down the track, you want to bring onboard a new person to the team. Like, how do you ensure that they also have the exact same versions of everything that you have? So the way we've solved that, well, I guess the solution that we came across that sort of works well for us is using something called DevContainers, which is something that it's just an extension you can install inside Visual Studio Code. It was also introduced into GitHub, so I don't know if you've noticed before, but like if you go and clone a repo now on GitHub, you also get this option of opening up inside something called GitHub Code Spaces. It's basically the exact same thing. It's just a dev container running inside GitHub. That's, I guess, the solution that we have. So what are dev containers? They're basically just Docker containers. Like, that's all it is. If you're familiar with like creating Docker containers, yeah, like it's basically the same thing. Inside the Docker container, it has all the common tools that you'll need in order to develop that piece of code that you're working on. So for us and my team, for example, we do a lot of Kubernetes stuff. So inside our dev container, we have things like K3D, which is just K3S running inside Docker. We also have K9S. We also have kubectl, Helm. Everything that we'll need in order to deploy it or to run our code. It's all basically, it's just all defined inside that one Docker container. It's transportable in that you can version it, you can build it once, push it up into your organization's container registry, and then you can just pull it down. So benefit of doing that is you can ensure everyone has the exact same environment running. So you also get some cool things where you can also run that dev container inside a CI/CD build pipeline. So if it works on your machine, you can pretty much guarantee it's going to run inside your CI/CD pipeline because you use the exact same environment that you ran on when you code it. It's going to run inside your CI/CD pipeline. And the other benefit is, when you're doing pull requests, a common thing, I don't know if we've all, I guess, sort of heard is, it works on my machine. This sort of solves that issue because you have the exact same stuff regardless of the machine that you're running on. So that's basically the benefits of using dev containers, and that's why we use dev containers. And every project we start on starts off by creating a dev container that everyone can work on. So that is what I wanted to talk about. I'll hand it over to Juan.
Cool. Thanks, Jason. My name is Juan Fernando Sarmiento Burckhardt. I'm a Colombian. That explains the long name, but that also means that I speak really fast and I have a strong accent. So good luck, bear with me. What I'm going to talk today, I'm going to talk about two scenarios that we see more and more when deploying to the edge. It's something that we have been doing in multiple projects, and it's a way that we found that it works. So that's what we want to share today. That was mentioned in some scars, so I'll talk about those ones. But first, I would like to talk a little bit about the evolution of the computers. Long ago, we used to work on mainframes. The people used to deploy their APIs in a mainframe. That was a big computer in headquarters that was not powerful, right? Then I make a big jump into the spoil era. I call it a spoil era because you hear more people saying in the middle of a conversation with operations guys, hey, I need a computer, I need 100 cores, I have 128 gigs of memory, and 2 terabytes of hard drive, right? Okay, here it is, you have 5. Yeah, I need dev, test, and prod. Yeah, you need more, here they are, click, 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 you get it. It's expensive, but you can get them, right? So that's the spoil era, it spoils us, at least at me. I can get it whenever I want, so that's one moment. Then we move into the edge, that's what we're seeing. A lot of these computations start moving closer to the real life, to the real world. How I define edge? I define edge as anything that is owned by the client that is not in the cloud and is not in headquarters. So that's something that is really tricky to follow, but let me jump into the next slide. The next slide, I'm going to talk a little bit about this DevSecOps, right? Everybody knows this flow. Everybody has seen it. You have code, you have APIs. You will see the same flow everywhere. The reason why I'm presenting this is because on the left side of this flow, we have what is going to happen with your code set. One trick that you have to keep in mind when you're working with IoT is that more and more we're moving into ARM. So when you're building your application, you have to consider your architecture as well. When I move to the right side, that is the place where we are working at the moment that I'm going to present the scenarios on, they have to do with your deployment, how you get your API into a device that is in the middle of nowhere. We call it DevOps on the bush, right? It's in the middle of nowhere, how you get a code set into there. So for that, I will jump into the first scenario, the partially connected scenario. To talk about this one, I will present three entities: the CI, the base station, and the leaves. I have been seeing different conferences. We have a similar situation in which each one of these entities appears. Let me give you a real life scenario. We want to monitor a forest, right? So you have all these leaves deployed in a forest, monitor, I don't know, water, snow, dangerous animals, anything, right? Then the device can do some computation, but it has to report back. That report comes back to the base station. The base station is way bigger, can do more modeling, has a bigger model. So imagine on that side you're detecting, in the other side you are classifying, right? And that base station can come into the lab and give all the details, get the latest model, you can retrain the model and get it back, right? So let me jump to some of the stages that I see, that we discussed. Everybody is disconnected, so everything works, right? If you cannot see it, it is working. So that's one of the stages. The second stage is when the base station can reach the CI. That's when you get internet. Here's one of the key concepts. We are caching in this situation. As soon as the base station can reach out to internet, we start caching, right? And the last stage is when the base station goes to the field, it can discover these leaves. That's another cool feature, and our discoverability. Then the base station can give details to the leaves. Let me put some icons to this, right? So CI, we have the same CI that you remember the left side of that flow. In this case, I'm putting GitHub. We have some GitHub actions. We have super cool code, is version linked, secure. It becomes a container. It becomes a container because we, as they were mentioning, as my colleagues were mentioning, we work on Kubernetes. We found that it's the most useful orchestrator for working on the edge, working on the cloud, working on premises. So once we have that, what we do is we want the base station to get these details. You can see an arrow from left to right. But what is happening, I don't know how many of you are familiar with Flags, we're doing a pull deployment. We're not doing a push, we're doing a pull. So whenever we arrive to the stage 2, you remember the stage that the base station can reach internet, we start caching. I put some drawings here, some icons, Harbor and GDA. We're using those tools to cache the registry. So we have, let's say, ACR, Azure Container Registry on the left. We cache it into Harbor. We have Flux repo in GitHub. We cache it into GDA. As soon as you have internet, we're bringing them. And we have this tool that is called EDO. We call it EdgeDevOps that help us to orchestrate all this, right? So it's a config-based tool that helps us to orchestrate this synchronization, this caching. And then when it goes to field, right, you can see our leaves. They're also running a cluster. In this case, I'm talking about K3D, really cool for testing for everything. And you see that we have another EDO service running here. This is the part that helps us for the discoverability. So we're using multicast DNS, we're using zero network config, and that's really cool because that's how we can make base station talk with the leaf. So the leaf is pre-configured to get the data from Harbor and GDA, and whenever it figures out, whenever it's in range, it will get the data. That's how you can deploy to the leaves. This is how we're deploying to the base station. So let me try to summarize this one. There are some features that we have here. The first one, we're caching on the base station. That means we're bringing the cloud into the edge. And then we have this zero config networking that helps us with the leaf discoverability. That is key for deploying new code sets into it. And then at the end, we have the leaf bootstrap. That's a process that we use to set up the OS of those leaves. So we have a script. It goes, creates the OS. You install it on your drone. You install it in your IoT device. And it will bootstrap with the configuration ready. So that's a scenario semi-connected. Let's talk about one of those crazy ones, the disconnected one. I have seen multiple people use disconnected and air-gapped really similar. Cool. So I'll go really fast with the. No, I won't go really fast. I'll go slow. But I'll try to go through this one. So what we have here is we have a CI and we have the device. See the device as the title said, a submarine, an airplane, something crazy, right? The CI is strong, and the only way to connect that one to that one is through a sneakernet. That's a concept that we use to manage everything that is how we connect A to B without TCP or IP. So there is no network. You have to take a physical device. Let me put some icons here. So we have something really similar to the previous one, but you can see the CI is going all the way to RKE. Because in our case, in this example, RKE is the target cluster. We take a snapshot of that environment and put it into a TV set file. So we compress that one. That's done through a tool that is called Zarf. That's a tool that we started to use a couple of months ago. I'll give more details about this one in the next slide. But we use this tool, it takes a snapshot, brings it into a single file. Then we can use some kind of a sneakernet device to bring it there. Imagine a USB that is encrypted and hashed. And then when we have it on the other side, we still use Zarf. That Zarf tool is going to use the TV set file, and it's going to deploy into the cluster. The cluster has to be initialized, so it can use the same APIs, right? But that's the way that we're deploying in a disconnected environment. Let me go really fast. Yeah, obviously, Zarf is not a silver bullet we're using. I know you're going to say, come on. But let's go through it. It has a big community on the back. You can see that they deploy day to day. Any new issue, it gets responded in less than 48 hours. The Department of Defense is using it in the US. That's the reason why we start to know about it. So when we see that Department of Defense is using it, that's really cool. And we see that it has a lot of power ahead. It has good documentation. It's Kubernetes native. So if you have your own operator, you can talk with it. And it's a single package. Who doesn't love a single package? Some of the challenges, don't kill me, it's not prod ready. But they are targeting the end of the year to have a production, V1. I think right now it's V022, but they are targeting the end of the year to have that one. Debugging depends a lot on your Kung Fu CTL skills. So kubectl, flags, everything that you know how to debug a cluster, it will be in there. Version control is not there, so when you have an image, when you have a TV set file and you try to apply the next one, it doesn't apply the diff, it applies the whole file, the whole binary. Yeah, it's a big binary. You can imagine all the containers embedded in it. Restricts Kubernetes, it uses some hooks, so it prevents that one. And it doesn't have validation and encryption out of the box. So those are some of the challenges that you will have there, but definitely suggest you to have a look. It's by Defense Unicorns, and it's open source in GitHub. I'll give it to Judas.
Thanks, Juan. I'll quickly go through the rest and finish up. So, like I said, one of the main problems we had is when we've got thousands of devices, how does discoverability work? So we turn to a set of technologies that your home network already uses. So if you're using a Chromecast, Alexa, or an Apple device, it uses a technology by the name of multicast DNS, or a variation of that. Basically what's happening is it's using UDP, multicast, or broadcast. It sends a query asking, let's say, what devices on the network have the printing capability, and a device that has the printing capability to respond again through multicasting saying, here's me, this is my IP, I can do it. And this is the same technology that we're using for devices thousands of devices in the network to discover one another, discover the capabilities, and it can even do things like load balancing, simple load balancing. I won't go into too much detail here, but if you are interested, there's a lot of, I guess, material on the internet about multicast DNS and DNS service discovery. To finish up, I just want to wrap up of the technologies that we've spoken about. So DevContainers, this is been our go-to strategy for inner development loop. For the pull-based GitOps type approach, look at Flux V2, I think, is what we've been using. And Harbor and GitEA are the tools that we use to cache the image registry and Git registries on the edge, on the base station. And Zarf is the tooling we use to package a Kubernetes cluster, then redeploy the same Kubernetes cluster on an edge device. Zarf is the most interesting tool that we've used out of this set. And finally, multicast DNS and DNS service discovery. This is a great way to have a disconnected set of tools, choreographed with one another, be able to discover one another, and to operate. So thank you for coming to our talk. We'll upload the slides to our Twitter. We are more than happy for anyone to approach us and have a chat. This is certainly the way that's worked for us. It doesn't mean it's the best way. We're happy to learn from any experience you've had. Also, if there are any, I don't know whether we've got time for questions. If there are any questions, happy to take them as well. Yes?
What are the challenges in the pull model for deployments?
Right. Juan, you want to take that? So I'll repeat the question. The question is, what are the challenges based in the pool method, the GitOps-based approach with Flux v2?
Cool. I'll say the biggest challenge is notification. Understanding when it gets applied on an edge device. So imagine you have 200 drones, right? Those 200 drones are going to start getting access to the network, it's going to start pulling, but you don't know when it is ready. Flux has a method that is the notification approach that you can assign an event when that is done, but you have to maintain it, right? That's probably the biggest challenge that you can see when you're using Flux, and it's the notification when the deployment is done. Otherwise, I highly suggest to use it. As I mentioned, if you have 200 drones, try to kubectl apply, and you don't know when the network will be ready, right? So that's a really cool approach. It's a GitOps approach. I think from my perspective, Flux is probably the best, the most maintained tool. There's also, I think in Azure, there is Arc, but there are different tools that you can use in a GitOps approach. But I think that's the biggest challenge that we have.
And to add to that, the other, I guess, challenge, it's more of annoyance than a challenge, is that like if you got Flux deployed or installed on your cluster and you're just deving against that, and then someone commits into the cluster and then all of a sudden like those changes get applied, that can get a little bit annoying if you're not aware of it. It's more of an annoyance than anything else, but yeah, that's the other thing, I guess.
Cool. Yeah, we've got a question here.
Have you written any of your own controls using the GitOps toolkit, or do you just leverage like the image automation notification controls?
I think the base set of controllers that comes with Flux were enough for us, unless...
Yeah, no, we use what is available. The thing is, you know how the notification service, you can enhance it a lot. So you can get the event the way that we receive it. We have that one. But by itself, notifying a new image, getting a new image deploy, updating Git itself is easy. So all that is coming out of the box from Flux. So, any other question? Or silence is golden? No, there's a question.
There's a question.
There's two challenges with Edge, obviously, is computational power for Edge devices, and then obviously the thing powering it itself. How do you maintain confidentiality of data between a sensor and a base station? Do you have any hints and tips or tricks that you do that gets around not requiring constant power or abundant compute?
To repeat the question, it's about how the edge device and the base station communicate. For our current work, we're using something called the robot operating system. And in that, there's a way of encrypting the traffic using security enclaves. So the robot operating system, and it uses a layer called DDS, or distributed data service. It's written in a way to use low power for these specific things. It uses a MTLS type, I guess, encryption on both ends to make sure that the traffic is encrypted and only the receiver and sender know about it. That's what we've been using, but I'm happy to take any other suggestions from anyone in the crowd as well. Come talk to us outside. We're more than happy to discuss some of the things that have worked for us. I think we're on time, and yeah. Thank you, everyone.
Thanks.